everyone. So today we're out, but we're doing a summary of curve sketching. So I'm going to walk you through some examples so that you can know enough to be able to do these problems and do them well. So this is section 4.5, summary of curve sketching. And let's just jump right in. So curve sketching really is just using everything that we've learned in this unit, putting it together to sketch a curve. So when you have to sketch an accurate curve, there are some things that you want to look for. Some things are old pre-calculus things, such as your domain, your intercepts, your x and y intercepts, your asymptotes, if you have any horizontal or vertical asymptotes. And then we get into the calculus stuff, which is really the most important, which is your intervals when you're increasing and decreasing, your local maxes and mins, your intervals of concavity, and your points of inflection. When you sketch a curve, you're going to make what I like to call a big F sign line. So by the time you get to the point where you're ready to sketch a curve, you should have already made an F prime sign line and an F double prime sign line in order to find your maxes and your mins and your points of inflection. So then you take those two sign lines, you put them together, you make a great big sign line, and then you're going to plot all of your points that you know and connect the dots with the correct shapes. So these are your kind of instructions, your steps for sketching a good curve. And then I'm going to walk you through several examples so that you can see how it all comes together. All right, so we're going to start by sketching the curve y equals 2x times e to the 1 minus x. The first thing that I want to check is we're going to check the domain. So just note that the domain for this is all reals. So our graph should go from negative infinity to infinity. There's no spots where we have any issues with our domain. I should also just mention, you know what, that's all I'm going to do for that. We'll get into intercepts and asymptotes and all that other kind of stuff later on. That should kind of flush out when we get ready to start sketching the curve. But knowing the domain is important because it helps you with your sign lines to know if you need to cut your sign lines off at any point. All right, so let's go ahead and start in with the first derivative. So our y prime, we're going to use product rule. It's 2e to the 1 minus x plus 2x times e to the 1 minus x times the derivative of 1 minus x, which is negative 1. So our first derivative is 2e to the 1 minus x minus 2xe to the 1 minus x. I'm going to go ahead and factor out a 2e to the 1 minus x from both terms, and I'm left with just 1 minus x once I factor those out. Now the nice thing about this, when I set this equal to 0, I want you to know that e to any power in the world can never equal 0. The e is a positive number. There's no power you can raise e to force it to be 0. So there are never any zeros from an e function. So really, the only critical number that we have is x equals 1 from this guy right here. All right, so if we make a first derivative sign line, our only critical number is 1. Again, e to any power is always positive. E to any power is always positive. Remember, even if the power is negative, that doesn't make the number negative, it just flips it over, right? E to the negative second is just 1 over e squared. So e to any power is positive. So this whole first part of our derivative is positive. So really, we're only having to check the stuff in the parentheses for our signs. So if I plug in a 0, I get a positive. If I plug in a 5, I get a negative. My function is increasing and then decreasing. I'm going to go ahead and take the time, because you know you're going to have to do this on your test, and I'm going to write all the characteristics for this function. So let's just go ahead, I'm going to switch colors and say y is increasing on the interval negative infinity to 1 because y prime is greater than 0 on that interval. Y is decreasing on the interval 1 to infinity because y prime is less than 0 on that interval. Whoops. Let's go ahead and erase and clean that up. There we go. 1 to infinity. All right, so at 1, if you kind of follow your arrows, we know that we have a relative max. So a rel max occurs at 1 comma something because y prime changes from positive to negative at that point. All right, how do we find the point? We plug 1 into our original function, so we get 2 times 1 times e to the 0. So e to the 0, of course, is 1, so you end up with just a y value of 2. All right, that's all we can do with the first derivative. There's no relative min, so now we're going to move on and do the second derivative. Now, there's all kinds of different ways that you could do the second derivative. Personally, I'm going to go ahead and use this factored form and do a product rule on that for my second derivative. So I think I'm going to go ahead and switch back to blue and say y double prime. So the derivative of 2e to the 1 minus x is 2e to the 1 minus x times the derivative of 1 minus x, which is negative 1, times 1 minus x, plus 2e to the 1 minus x times the derivative of 1 minus x, which is negative 1. Please be super, super careful with your signs. I'm going to go ahead and distribute first and then clean it up. So I end up with negative 2e to the 1 minus x plus 2x e to the 1 minus x minus 2e to the 1 minus x. So I end up with 2x e to the 1 minus x minus 4e to the 1 minus x. So when I factor this out, I have a 2e to the 1 minus x times x minus 2. If I set this equal to 0, did I set my first derivative equal to 0? Oh, I did, good. Okay. If I set this equal to 0 and solve, this guy has no solution. This guy has the solution x equals 2. So x equals 2 is our only critical number for our second derivative. So if we make a y double prime sign line at 2, remember this 2e to the 1 minus x is always positive. So if I plug a 0 in to my function, I get a negative. If I plug in a 5, I get a positive. My function is concave down and then concave up. So I'm going to write these answers. I'm going to say y is concave down on negative infinity to 2 because y double prime is negative on negative infinity to 2. Y is concave up on 2 to infinity because y double prime is positive on 2 to infinity, and a point of inflection occurs at 2 comma something because y double prime changes sign at that point. All right, where do we find the point for the point of inflection? We go back to the original function, so I'm plugging in a 2. So I get 2 times 2 is 4 times e to the negative first. So my y value is 4 over e. All right, all of that should be a review. Everything that we've done so far has been a review. The next thing that we're going to do now is we're going to make what I like to call a big F sign line. So a big F sign line is where you take everything that you've done so far and you put it on one great big line. I'm going to check to make sure nope, I wanted to see if I had a grid available, but I didn't. This is a make your own grid. So our first sign line only has a 1 on it, and it's positive and negative, so increasing, decreasing, and then the second sign line has a 2. So I'm going to take everything from both sign lines. So I have a 1 from my y prime sign line, and a 2 from my y double prime sign line, and I'm just going to make a big y sign line. So I'm not going to put the pluses and minuses, I'm actually going to put the little symbols. So my function was actually increasing and then decreasing after 1. So we were increasing before 1, decreasing after 1. We are concave down until 2. So we're going to transfer the concave down symbols all the way until 2, and then after 2, we were concave up. Now from here, I'm going to show you how to write the shape of the graph. There's a cute little trick, and I'm going to kind of do it down here and then erase it. When you have increasing on a concave down function, what you do is you take the part of the concave down function that is increasing, that part right there, and that is the shape that you're going to put for your graph for that section. From 1 to 2, we're decreasing on a concave down function, so you take the part of your concavity symbol, your concave down symbol, that's decreasing, and you kind of draw it under there. For the last part, we're concave up. I don't normally draw a big symbol. I usually just look at these little guys, right? So I look for the part of this symbol that's decreasing, and I just draw its shape down here. So I am decreasing concave up. So there are 4 different shapes you can have. We have increasing concave down, decreasing concave down, increasing concave up, and decreasing concave up are the 4 possible shapes. We have 3 of the 4 on our sign line. So let's take a look now at what points we have to plot. So we know we have the point 1, 2 is our relative max, and we know we have the point 2, 4 over e. So I'm going to just rewrite those over here. So we have a rel max at the point 1, 2. We have a point of inflection at the point 2, 4 over e. We also know our original function, which is 2x e to the 1 minus x. If we wanted to find out where this equals 0, this is 0 at x equals 0, which means we are going to have an x-intercept at 0. If you plug in a 0, you also get 0. This is actually both the x and the y-intercept. It's going to pass through the point 0, 0. Okay, so there's our intercept. There are no vertical asymptotes, and let's just take a look and see, without worrying about the horizontal asymptotes, let's see what the graph does to guide us here. So I'm going to draw it kind of like this. Okay, and let's go. All right, so we know we have a point at 0, 0. We know we have a point at 1, 2. We also know we have a point at 2, 4 over e. We don't know what 4 over e is, but you can, when you're graphing, just think of e as being around 3. So the point there would be 2 around 4/3. So 4/3 is just a little bit above 1, so there's a point right around there. Once you have all your points plotted, it's time to connect the dots using the correct shapes. So from negative, like look at your big F sign line. From negative infinity to 1, you want that shape. Make sure you connect your dots. So I'm going to connect my dots with this kind of skinny, increasing concave down shape. Then from 1 to 2, I'm going to connect the dots with a decreasing concave down shape. And then from 2 to infinity, I'm going to connect the dots with a decreasing concave up shape. Be careful. Remember, my only x-intercept was at 0, 0. So I cannot cross the x-axis again because that would mean there'd be more than one x-intercept. So what I have to do instead is follow along like that and stay positive. So there actually ends up being a horizontal asymptote at 0 as x approaches positive infinity, which we could do with some limits, but that's okay. We kind of can figure it out just by thinking about it. And there is our graph. All right, so we're going to do this problem. This is an actual AP question from 1996. Notice this one is one of the types of questions where instead of a function, they give you the derivative. So they've given us the graph of the derivative. This is the graph of f prime, the derivative of f. Notice that the domain is the set of all real numbers from -3 to 5. So we are given the domain is from -3 to 5. So for what values of x does f have a relative max and y? And for what value relative min, and then concave up. So from our graph, I'm going to go ahead and make our two sign lines. I'm going to make an f prime sign line and an f double prime sign line. Notice both of them have to be restricted between -3 and 5. The critical numbers of f prime, the critical numbers that go on our f prime sign line, are the x values where the derivative, where f prime is 0 or undefined. This is f prime. This is the derivative of f. This is f prime. F prime is 0 here, here, and here. It's never undefined. So our critical numbers are -2, 1, and 4. Now, for signs, you literally look at the sign. Is it above the x-axis or is it below the x-axis? From -3 to -2, f prime is positive. From -2 to 1, f prime is negative. From 1 to 4, f prime is still negative. And from 4 to 5, f prime is positive, which means our function is increasing, decreasing, decreasing, increasing. I'm going to go ahead and make the f double prime sign line now, just so that you can, and then we'll just answer all the questions at once, so you can see the difference. When you're making an f double prime sign line, remember f double prime is positive when f prime is increasing. F double prime is the slope of f prime. So when f prime is increasing, f double prime is positive. When f prime is decreasing, f double prime is negative. So the critical numbers for f double prime are actually the maxes and mins of f prime. So the critical numbers for f double prime would be -1, 1, and 3. From -3 to -1, f prime is decreasing, so f double prime is negative. From -1 to 1, f prime is increasing, so f double prime is positive. From 1 to 3, f prime is decreasing, so f double prime is negative. And from 3 to 5, f prime is increasing, so f double prime is positive. I'm going to fill in our little concavity symbols. All right, and now we've got both of our sign lines, and now we can answer all of our questions. So for part A, for what values does x does f have a relative max and y? F has a rel max at x equals -2 would be the only spot where you have a relative max because f prime changes from positive to negative at x equals -2. So that would be our answer for part A. For part B, I'm just going to write it down here. F has a rel min at x equals 4 because f prime changes from negative to positive at x equals 4. Our last question, on what intervals is the graph concave up? Use f prime to justify your answer. The graph is concave up from -1 to 1 and from 3 to 5. So you would say f is, I'm going to abbreviate, concave up on -1 to 1, union 3 to 5 because, now normally we'd say because f double prime is positive, but they want us to use f prime, so we would say because f prime is increasing on those intervals. That's how we knew f double prime was positive. All right, so those are our answers to all of those questions. There's still one more part to this problem, which is on the next page. In the next page, part D, it asks us to sketch an accurate graph of the function, but only on the interval from 0 to 2. So we don't have to copy all of our sign lines. They only want us to graph the shape from 0 to 2. So I'm going to go ahead and make a big F sign line from 0 to 2. And notice they give you a point here. They tell you f of 1 equals 0. When you have the graph of a derivative, there's no way to know what actual y values are on your function. All you know are slopes. So you can't plot points unless they give them to you. So in this case, they gave us that 1 point. So I'm going to look from 0 to 2 on my first sign line. So from 0 to 2 kind of falls in here. From 0 to 2, my f prime is always negative. There is a critical number at 1, but from 0 to 2, it's always negative. So if I put a 1 here, my f prime is always negative, so my f is always decreasing. If I look at my f double prime, from 0 to 1, my f double prime is positive, and from 1 to 2, my f double prime is negative. So I am going to say from 0 to 1, my graph is concave up, and from 1 to 2, my graph is concave down. Underneath my big F sign line is where I kind of draw what the shape should look like. So I'm looking for the part of the concave up symbol that's decreasing, which looks like that, and then the part of the concave down symbol that's decreasing, which looks like that. All right, we are ready to graph. Suppose f of 1 equals 0. We've got that. All right. There is graph beyond 0 and beyond 2. So don't draw asymptotes because there aren't asymptotes there. We don't know what the y values are, but we know there's not an asymptote at 0 and 2 because the derivative was defined, and if there were asymptotes, the derivative would be undefined. So all we're going to do is just pick a random spot on the y-axis to start, and we're going to draw a function that is decreasing concave up, and then decreasing concave down, and then we just stop. At 1, kind of make sure that your slope goes horizontal because we want to emphasize, even though there's not a rel max or min, we do know that the slope is 0 there because the first derivative was 0, so your graph should have a horizontal tangent at 1. And that is it. So hopefully you've gotten enough out of this lesson to be able to sketch a curve